Question 9. Coil 1 has an inductance of 30 millihenry and 150 turns, while coil 2 has an inductance of 40 millihenry and 250 turns. So the mutual inductance is 4 millihenry, and at a particular instant the current is 5 milli. Okay, the current is 5 milliampere through coil 1, and this current changes at a rate of 4 ampere per second. So we have to determine the flux linkage in coil 1. Flux linkage is N phi, which is also equal to the inductance times the current. Okay, so the inductance untuk coil 1 is L1, I is just I1 lah, which is 5 milliampere. Okay, so this will gives you 1.5 times 10 negative 4 Weber. Okay, and then flux linkage in coil 2, so we do not have the current path going through coil 2, so we are going to use the mutual inductance punya formula, because we can then relate that with coil 2 lah. So this is current 1, so N2 is equal to M I1, so this is M I1 divided by N2, which gives you 2 times 10. Good job. I have to calculate this because it's not given in the notes, and it shouldn't be Henry. So why is the answer scheme showing Henry here? Let me double check. So M is 4 millihenry times with current in 1, which is equal to 5 milliampere, divided by the number of turns for coil 2, which is 250. So this is giving us the value of 8 times 10 negative 8 Weber lah, magnetic flux linkage kan in coil 2. Okay, that is what I've got. Not sure if you got the same thing, but let me double check again. Dia tanya apa? The flux linkage in coil 2. Okay, so if you don't divide it with the number of turns, if you just stick it here, you will get 2 times 10 negative 5 Weber lah. Okay, but I think personally flux linkage, we should times it with the number of turns, right? But for that one, I'll double check with you and write it in the description of this video lah. Okay, alright, so question C pula, induced EMF in coil 2 is just the mutual inductance and the rate of change of current in coil 1. So this will give us 1.6 times 10 negative 2 volt lah. Okay, so this one should be in Weber lah kan? Yes. Okay, so yeah, that is the solution for question number 9.